Welcome back to lecture. I'm going to go over Lesson 8 today, Inequalities, as part of our Algebra Review. So Emily wants to earn an A in her college algebra club course and knows that the average of her tests and assignments must be at least 90 for her A. She has 5 test grades of 96, 84, 80, and 98, and 88. She also has a score of 100 for her online homework, and this carries the same weight as a test grade. She still needs to take the final exam, and the final is weighted as 2 test grades. To determine the scores on the final exam that would result in an average of 90 or more, Emily would set up and solve the following inequality, where she had all of her test scores, her online homework, and then the score on her final, but times 2, and this is counted as 8. 1, 2, 3, 4, 5, 6, 7, 8. And that needs to be greater than or equal to 90, so this is the average for those. In this lesson, we will learn how to solve inequalities like Emily's as well as other forms of inequalities. So let's get started. First thing we're going to talk about is linear inequalities in one variable. A linear equation in one variable is an equation that can be written as ax plus b is equal to 0. We've seen that before, where a and b are real numbers, and a is not equal to 0. A linear inequality is any relationship of the form ax plus b either less than 0, ax plus b less than or equal to 0, ax plus b greater than 0, or ax plus b greater than or equal to 0. And the solution set to a linear equation consists of that single element that can be represented by a point on the number line, the unique solution. The solution set to a linear inequality contains an infinite number of elements, or could contain an infinite number of elements, and can be expressed in set builder notation or in interval notation. So this kind of summarizes down here what we were just saying. If I've got an equation or an inequality, if I say x plus 4 is equal to 0 and I solve -4, -4, that's just a singular point, -4. If I graph that, I just draw the line closed in at -4. But here's an inequality. I'm saying I want all the numbers so that when I put a number x, add it to 4, I get greater than or equal to 0. So here I'm solving similar to how I did this. I subtract -4, subtract 4 from both sides, and then I get x greater than or equal to -4, so there's the solution set. Here is the interval closed because I'm including the -4, and this is the graph on the number line. So it's all these points in blue bigger than -4. How about x plus 4 less than 0? I solved the very same way, -4, -4, but I'm left with x less than -4. Here's our set builder, the set of all x, such as x is less than -4. So those are from -infinity up to -4. I'm not including it because I have no equal sign. And when I graph this out with the parentheses here, that's all those numbers to the left are smaller than -4. So here's how we're going to here's the properties of inequalities that we're going to use to solve and graph those the systems of the solutions. So a, b, and c are real numbers. If x is less than a, then a is bigger than x. X is smaller than a. Here's the big side, so a is bigger than x. If a is less than b, b is less than c. A is less than C. A is less than B, B is less than C, and this is a transitive relationship. A is less than C. If I've got 2, A plus B and C is less than D, if I add these two, A plus C should still be less than B plus D. Two numbers that both are smaller here are going to be smaller than those numbers when I add up the larger numbers. If A is less than B, then I can add the same number C to both sides. A plus C is still less than B plus C. And I can subtract the same number from both sides, and I'd still have something where it would maintain the order of this relationship. A minus C would still be less than B minus C. So if I've got a positive number C, and if I've got this relationship, A is less than B, I can multiply C by both sides, and that maintains that relationship. AC would still be less than BC, and if C is positive, I can do the same thing with division. A divided by C is less than B divided by C. Now here I emphasize the positive. C had to be positive for this to maintain that relationship. If C is negative, we actually have to flip it. If A is less than B and C is negative, if I multiply a negative number by both sides, I actually have to change that relationship. So now it started A less than B, AC is bigger than BC, and similar for division, A divided by C will be bigger than B divided by C. I've had to flip that relationship. So these statements are also true expressed with the symbols greater than, less than or equal to, greater than or equal to. Once I recognize the inequality, I can do all these things, but only so everything's going to be fine up to this point. I'm going to have to flip this one, flip this one, flip this one if I multiply or divide by a negative number. And this one kind of summarizes the statement here. So let's take a look at a couple of them and see how we start to solve equations dealing with inequalities. So here, solve the inequality, graph the solution set, and then write the solution in set builder notation and in interval notation. So I start with my inequality, minus 6x plus 4 less than 0. And similar to what we do when we're solving equations, I want to get all my constants over on the other side. This is a linear, so I'm going to subtract my 4, the opposite. So my 4 minus 4 would be 0 here. I got to do it to both sides. My 34 minus 4 would be 30 on this side. And now I'm going to divide, to get rid of this negative 6, I'm going to divide by negative 6, divide by negative 6, but as soon as I do that, notice I have to reverse that inequality order. So this is the less than, now it's greater than. I want to do this just as quick as I can so I don't forget to change that sign. And here I've got x greater than negative 5. So this is 30 divided by negative 6. And now I just need to graph it out. Set builder, set of all x such that x is bigger than negative 5. There's my solution. I can find my negative 5 on my number line. Here's the negative 5. I want strictly bigger than, so I do it as a parentheses and not a bracket. And then graph all the way out, all the numbers bigger than. Interval notation, negative 5 to infinity. So here, stop our lecture and take a look at this and see if you can work this. Minus 5t minus 6 greater than or equal to 24. So let's see how you did. If I write down minus 5t minus 6 greater than or equal to the 24, I want to get rid of my constants over here because I want that t by itself. I'm going to add plus 6 to both sides. I'll get my minus 5t greater than or equal to 30, and then I'm going to divide out my negative 5. And when I do that, I'm going to switch the order as soon as I do that. So here's the solution. T is less than or equal to negative 6. Here's my graph, my set builder notation, set of all t such that t is less than or equal to negative 6. And here's my interval, negative infinity up to negative 6. I'm including that, and there we go. So here's another one involving irrational terms. I've got x plus 1 over 3 minus 2x minus 4 over 6. I want to find the solutions when that is less than or equal to negative x over 2. So this is similar how we handle rational system when we're dealing with equalities. I'm going to multiply both sides by the LCD to clear these fractions, and then all I have to do is get my x's on one side, my constants on the other. So my LCD in this case is 3. This is factored 3 times 2, so my LCD has already got a 3. The 2 is in here, so 6 is the LCD. I multiply both sides by my 6. It's a positive number, so I maintain that relationship. When I distribute my x here, 3 will go into 6 2 times, so it's 2 times x plus 1, 2x plus 2. minus the 6 cancels here, and I'm just left with a minus 2x minus 4, or minus 2x plus 4. I have to distribute that one. And here I've just got left the minus 3x. So in this case, the 2x and the minus 2x canceled. I've got my 6 from my 4 and my 2 grouping. Minus 3x, I'm going to divide both sides, and when I do, I'm going to switch that order of the relationship from a less than over on this side to a greater than. And here, so that negative 3 is canceled, my x is less than or equal to negative 2, or I'm rewriting, here's 0, the smaller number is x, all numbers x less than or equal to negative 2, and if I graph that on the number line, there's my negative 2 I'm including, and all the ones smaller to the left, more negative. And here's my solution set in set builder. Set of all x such that x is less than or equal to negative 2, and an interval negative infinity to negative 2. So let's take a look now at compound inequalities. So in this section we learned to solve compound inequalities. These are statements with 2 or more inequalities joined by the word either and or the word or. For example, suppose that x represents the glucose level measured from a fasting blood sugar test. The normal glucose range is given by x greater than or equal to 70 milligrams per deciliter and x less than or equal to 100 milligrams per deciliter. An abnormal glucose level is given by x less than 70 milligrams or x greater than 100 milligrams. To find the solution sets for compound inequalities, we're going to do this. We're going to solve each one of these inequalities. Here they're just given it, so we would graph them out, graph this side out, and then look for what the word is that's joining these things. I need the and solution, so it must satisfy both, or solution, it satisfies either. And then we'll just state them. We can graph them or do set builder notation from that point. So let's take a look at one. Solve this. Negative 2/3 y bigger than negative 12, and the and is the intersection. We've looked at that earlier. 2.08 greater than or equal to 0.65 y. So I'm going to solve this for y. All I'm going to do is do the inverse, so that I'm going to inverse negative 2/3, the reciprocal, so that my 3's cancel, my 2's cancel, and I've got a negative and a negative. I'm going to switch the order because I'm doing a negative here. Everything cancels on this, that gives me the y, and then just 2 into negative 12, negative 6, and negative 3 times negative 6 is my 18. So over here I'm going to graph this out. All the numbers less than 18, strictly less than, so there's my parentheses all the way out. And then I do something similar for this. I'm going to divide by my 0.65. Positive numbers, I maintain the relationship order. I got a y, and here when I divide by 2.8 by 0.65, I get my 3.2. These are the y's less than. I just rewrite this so that this is the smaller to the left. Y less than or equal to 3.2. The equal sign, so I've got my bracket. Now I needed things and. Notice that all of these numbers in here, let's say 15 is in this one, but it's not in this one. It has to be in both, so I don't include any of these. All the way up to 3.2 is in this one, so that's my solution set because I have an and. And here's my final graph. If I wanted to do set builder, I would say the set of all y such that y is less than 18 and y is less than or equal to 32, or I could write set of all y such that y is less than or equal to 32. That would be the and, simplified. Here's an OR situation. We're going to do the very same thing. We had the very same solutions, but I'm just using an OR, and what would that be? So this could be in this or this. Well, naturally, all of these are in both of them, so it doesn't matter. But here's ones that weren't in the and situation. So it's in this, but even though it's not in that, I get to go all the way from negative infinity up to 18, which is in the neither. So here's just a little more complicated. I've got to actually solve a little more here before I can get to it. X minus 2 less than 5 or 1/2 x is greater than 6. So I do both of them. I have to solve both pieces. X minus 2 less than or equal to 5 plus 2 plus 2. X is less than or equal to 7, the equal, and here's that graph. For this side, I'm going to multiply both sides by 2. That gives me x greater than 12, and here's that graph on the number line. Now, either one of these would work, so it's basically either this one or that one, and I just join the two of them on the number line. So now I get the solution set of all x such that x is less than or equal to 7, or x bigger than 12, and this is the interval notation. This should be negative infinity up to 7, comma 7. That's missing in there, but then union, that's the big U, 12 to infinity. So solve this one. Negative 1/4 t is less than 2 and 0.522 greater than or equal to 1.3. So I solve this one, multiply both sides by negative 4/1 to cancel both sides. This turns this, and I have to reverse the relationship since I'm doing a negative number. Divide both sides by 0.52 here, and then this gives me t greater than or equal to 2.5. So let's graph these to see what that and relationship looks like. Here's the first solution for here. Our t greater than or equal to 2.5 is here, and it has to be in both of them. Here, this number in this one is not in both, so we can't include it. These are just the overlap. So that's in the intersection. So the solutions have t, set of all t, such that t is greater than or equal to 2.5. And our interval notation is left bracket include 2.5 out to infinity. This is called a three-part compound inequality. Here I can represent this as 2 because I've got this. Basically what this is saying is I've got two inequalities. The first is 5 is less than negative 2x plus 7. The second one is minus 2x plus 7 less than or equal to 11. I can put this in just by this one statement, and basically I can solve it just by operating on all three at one time. And basically what I want to do is isolate the x in the middle. So here I'm going to go negative 7, negative 7, negative 7 all the way through 3 pieces. That's going to get rid of that 7, and I'm left with the negative 2 less than negative 2x less than or equal to 4 from the 11 minus 7. And now I'm going to divide through by minus 2, and notice I'm going to switch the order of everything. Right there, it goes from greater than or equal. Here's the negative 2 divided by 2. Negative 2 is 1. There's my x, and this is greater than or equal to negative 2. And I like things from left to right, smaller to larger, so I go just flip everything but maintain these order relationship. The negative 2 is the small side, the x is the big side, and then x is less than, and there's the 1. Here's the graph, negative 2, all the way up to 1, and 1 is not included. The set builder, the set of all x such that negative 2 is less than or equal to x less than 1, and an interval notation, negative 2 up to 1. Here's another one. Let's solve negative 16 less than or equal to negative 3y minus 4 is less than 2. So this is this piece and then that piece. There's two separate ones. But all we're going to do is focus on the middle and then isolate that 1y by itself. So I'm going to add plus 4, always the constants first. That gives me negative 12 less than or equal to negative 3y because that went to 0. And then the 2 plus 4 is the 6. Now I'm going to divide all 3 sides by my negative 3. I could have come down here with another line, but I just added that to save some space. But once I do that, remember I have to change the order. Negative 12 divided by negative 3 is 4, bigger than or equal to y. bigger than -2, and I just like to write those left to right. -2 less than y less than or equal to 4. There's my solution as set builder. -2 less than y less than or equal to 4, and an interval -2 up to 4. So let's take a look at inequalities involving absolute values. So we've looked at absolute values before, and but now we're going to do them with absolute values dealing with inequalities. So here, if I have an absolute value, and if I have an absolute value of x is less than 3, that's saying the distance between x and 0 is less than 3, and less than 3 units. So that would be all of these would be less than 3 units from 0. All of those would be less than 3, not including the 3. So that's basically what that means. So here's the solution set. The set of all x such that -3 less than x less than 3. And if I've got something bigger than 3, the absolute value of x is bigger than 3, that tells me these x's have to be bigger than 3, or they have to be less than -3 because I'm taking the absolute value of these things. And the absolute value is always positive. So the absolute value of -4 would be +4, and that would be bigger than 3. So here I have to break these apart. Here I can use that compound. Here I have to break them apart into 2. So this is the property that we just kind of looked at, but I'm going to just write it out. And then that's how we're going to solve things that are larger than that simple absolute value. So for any real number k positive, because the absolute value of k always has to be positive, this particular absolute value inequality, the absolute value of u less than k, is equivalent to this compound. Minus k is less than u is less than k. And that's how I'm going to remove the absolute value to be able to look at a solution set. If I've got some absolute value of some number or expression u greater than k, that's the equivalent to it's either the expression is less than -k, all those numbers or expressions, or all the numbers or expressions bigger than that k. And just as a note, this also holds for less than or equal to, or greater than or equal to. And this is basically what this is from having the negative u if u is less than 0. That we've looked at this before to break open this part of it. So let's see how we use that property. Solve the inequality and write the solution set in an interval notation. So +3 to get that by itself. So I've got 2x minus m minus absolute value minus 3 less than 7. I want to do +3 to get rid of this -3. So +3 gives me the 10, 7, 8, 9, 10, and then I want to divide by 2. So this would be to isolate the 6 minus m absolute value, and the 10 divided by the 2 was 5, maintain the order. And now I look, I've got the absolute value of something, I've got an inequality, in this case less than. So the less than I break out as -5 less than 6 minus m less than 5. And then I just solve for m in the middle, I just squeeze that one. -6 minus 6 all the way across. Minus 11 is less than -m less than -1 because I had the 5 minus 6. And now I want this to be plus m, so I'm going to divide all 3 by -1. And when I do that, I need to swap the order of the inequalities because of that -1. So now it's 11 bigger than m, bigger than 1, and I want them from left to right, small to large. So I'm just going to rewrite this. Here's the small size. Here's the big one. 1 left than m. M is less than 11. And if I graph it, those are all those numbers that would work. Set builder, set of all m1 less than m less than 11. And there's the interval notation. So let's pick a number in here and just see if this works. Let's pick 10. 6 minus 10 is negative 4. The absolute value would be plus 4. 2 times 4 is 8. 8 minus 3 is 5. And 5 is less than 7. How about 20? 6 minus 20 would be minus 14. Absolute value plus 14. 2 times that, 28 minus 3 is 25. And that's certainly not less than 7. So here's another one again. I've got 3 times the absolute value of 4 minus x. Minus 2 is less than 16. Plus 2 to both sides gives me 3 times the absolute value of 4 minus x is less than 18. Divide by my 3. This is a positive number, so I still maintain that relationship order. It's less than 18 over 3. So I've got 4 minus x is less than 6. And here is where I've got that absolute value of u less than 6. I break that out as negative 6 is less than 4 minus x, and that is less than 6. So now I'm just solving for x. Minus 4 gives me negative 10, less than negative x, less than 2 from the 6 minus 4. And then I divide through by negative 1, change the order, 10 bigger than x, bigger than negative 2. And then I rewrite here because I like left to right, smaller to larger. The negative 2, less than x, that's the smallest, up to the biggest is 10, and I do not include either one. And there's the interval notation. So what about, we've got, this one's going to end up with another version. So I want to solve this. Basically, I want the absolute value by itself. So I've got negative 4 greater than or equal to negative 2 times this. So I'm dividing both sides by negative 2. I switch the order. 2 less than or equal to 3x plus 1, or equivalently, the absolute value of 3x plus 1 is bigger than or equal to 2. This is the bigger than version. So here I have to split this out to two versions. This is either less than or equal to negative 2, the negative of it, or what's inside is bigger than or equal to 2, positive version. And then I just solve both cases. Minus 1, divide by 3, so that's negative 3 divided by 3 is my negative 1. Minus 1 gives me the 1, divide by 3, so x is either bigger than 1/3 or x is less than or equal to negative 1. So those are disjoint. Here's this piece, that piece, and there's obviously some things in the middle that's missing. So here is this in interval notation. This, from the negative infinity to negative 1, include union 1/3 out to infinity. So either numbers in this set or that set would work. So let's look at one more. Minus 2, that would be 8 less than or equal to this. Put this around, this is bigger than 8. This is the big side, I'm just listing it there so that it looks familiar. Bigger than this, so I have to break it out. It's either less than, this on the inside is less than negative 8, or it's bigger than 8. Solve plus 4, divide by negative 5, change the sign, the order right here, and that gives us c bigger than 4/5. Plus 4, divide by negative 5, change the order, or c is less than negative 12/5. So here's this piece from there, and then there's that piece in there. Here's some special case solutions that if you're working and all of a sudden you come up with, you can specify right off the bat whether there's a problem or the solution. Here I want to say x plus 2 is less than negative 4. Here is a special case solution. There is no solution. Okay, that's the empty set. There's no solution. There's no way that I can have an absolute value, these are positive numbers, being less than a negative number. So that's saying that that would be negative as well, and there's no x's in here that I can make this be a negative number. So the solution set is empty set. There is no solution. What about this? X plus 2 greater than or equal to negative 4. Well, the absolute value is always greater than or equal to 0. So it doesn't matter anything in here is going to be bigger than a negative number. So this is the solution set is all of R. No matter what x we put in there, 0, the smallest is going to be the 0, which is the 2. Absolute value is 2 is bigger than or equal to negative 4. And then all the other numbers are going to be bigger than that. If this was negative 2, excuse me, if this was negative 2, that's going to be 0. And even 0 is going to be bigger than or equal to negative 4. How about the x minus 5 is less than or equal to 0? This is okay. The equals 0, it's never going to be negative, it's never going to be less than 0, but I've got the included this. So it is the only point that that's going to work is when it says equal to 0, and that just means that the inside has to be equal to 0, which means that x is equal to 5. So the solution set is absolutely is 5. Just that point only. What about x minus 5 greater than 0? The only time this is 0 is going to be when x is equal to 5. So I have to pull out the 5. So this is, again, if we rewrote this, this is x minus 5 greater than 0, x minus 5 less than 0. And that just does not include the 5. So that's the all real numbers excluding the 5. And that's how we pull out 5, remember, from the interval notation. So remember Emily when we first started this lesson? Emily has test scores of 96, 84, 80, 98, and 88. Her score for online work was 100 and is weighted as a test grade. And then she still needs to take the final exam, which counts as 2 test grades. What score does she need on the final exam to have an average of at least 90? So the least is the smallest, and she wants that number to be bigger than or equal to that. So here was our inequality that we had at the start of the lesson. I'm going to group all of these numbers together. That would be 546 plus 2x over 8 bigger than 90. Let's clear fractions. The only thing I've got to do is multiply both sides by 8 to clear that. 8 times 90 would be my 720. I want my x by itself on this thing, so first get rid of the 546, subtract. 2x is bigger than 174, and then I'm going to divide by 2, and that just happens to be 87. So that says Emily must earn a score of at least an 87. Anything bigger than 87 makes this bigger than 90. Okay. So that includes this lesson. We will see you next time.